When we look at chain rule, it is used to find the derivative of a composite function. Where have we seen the phrase composite function before? All right, so where have we seen composite function before? Do we remember the phrase? No, we don't remember that phrase. Composite function should bring to mind something like this. Do we remember that? Okay, well, we didn't have the word right, but we knew that it was a thing. Okay, f of g of x, where there's a function within a function. Okay, so basically, if at any point in time you have something where there is an outside, and I'll just say something to the nth power. It can be a 1/2 power. It can be a 3rd power. It can be a 7th power. Whatever it is, something to a power. Now, it's not always to a power because there's trig ones like this that we'll talk about. So if there is like an outside function and an inside function, okay, then you need the chain rule. So just like product and quotient rule, we have a definition of what this is. So if you have a function inside of another function, then here's what you have for your derivative. The derivative of f, so f prime of x, with your inside function still plugged in. But then you must multiply by the derivative of that inside function. Okay? This is why it's called the chain rule, because it's like there's links to pieces. It just keeps going because there can be more than two functions. And we'll see that today too. A function within a function within a function. Okay? In other words, just kind of in English, like I told you when I memorized the product and quotient rule, I kind of memorize an English version, like derivative of the first times the second and so on. Basically what you're doing here is the derivative of the outside function. Well, how am I writing this? Sorry, I need my English version. You're going to do the derivative of the outside function and multiply it by the derivative of the inside function, which that's my derivative notation there. Okay? I don't like that. That looks bad. All right. So we're going to take and do a straightforward one of these. Okay? More straightforward, I should say. So question 1 is where we're going to start with. Now, in earlier days of this, we had something that looked similar to this that might have said like 3x plus 5 squared. In our earlier derivative rules, we said, well, I can't do the derivative this way, but can I simplify that? Yeah, so what did we do with that? We FOILed it all out, and that worked great for 3x plus 5 squared. Do you really want to multiply out 3x plus 5 to the 7th power? No, and that's just not practical. We're not going to do that. So because we have higher powers that we can't do that to, or like a 1/2 power that we can't do that to, we have the chain rule. So the first step in doing the chain rule is to identify what your outside function is and what your inside function is. So think of it as like your f of g of x. So for example, because you'll probably stare at me if I ask you what it is on the first one, I would say on 1, my outside function is something to the 7th power. Okay? You could say it like it's an x, but I'm going to write it as a something because there's something in there and it's not just x, right? What is inside there? 3x plus 5. That's my inside function. Now, you don't have to write this every time. Like, if you can see it and it's in your head, great. If it's not and you need to write it every time till you get it, also great. Okay? So if it was just an x to the 7th, how would you take the derivative of an x to the 7th? Yeah, you'd bring the 7 down. You'd keep the x, whatever that x happens to be, and you'd subtract 1 from your exponent, right? But there wasn't just an x in there. What was in there? 3x plus 5. So that stays inside. It doesn't affect how I take the derivative. I still bring the 7 down front, and I still subtract 1 from the exponent. It's just that that's like a big base. You just say that's still in there. The additional part to that, though, is that we then multiply by the derivative of the inside function. So what is the derivative of that 3x plus 5? 3. And all you do from there is simplify. Yes, ma'am?
So isn't the inside function the 3x plus 5 and the outside is like the 7?
Mm-hmm. Yeah, that's correct. So then from there, what can I simplify?
7 times 3.
7 times 3. All that gives me is what? 21 Now, please remember your algebra rules and do not try to distribute that 21 into the 3x plus 5. Someone will try to do that somewhere, so I just say it now. That's like locked in there. Can't do anything. Okay? All right, before I do another one, because that's our first one. Oh, what kind of questions do we have? Yeah? As always, we need to simplify first. The fly is taunting me. It is on my iPad. If I hit it, I will not get it. It hates me. Ah, see? Now that's on. I'm also recording. That is going to be my video lesson, and we don't care because that's my personality right there. All right, the fly has taunted me for 2 days. Yeah, if you didn't catch that, I've been chasing that fly around this room for 2 days. 2. It's taunting me at this point. All right. I know, she didn't yesterday. All right. Before I can do my chain rule in number 2, I have to rewrite it. Okay? How must I rewrite in number 2? If anything is on the bottom, what have we been doing with the stuff on the bottom? Bringing it up with what kind of exponent? A negative. All right, so I'm going to do 2 things at once. I'm going to bring up the 2x minus 1. I know it's going to have a negative exponent. And what kind of exponent is a square root? Negative 1/2 there. Okay? So, if you can ever rewrite it, you know, we kind of said up here, it's like something to an exponent. That's how I'm trying to rewrite it. Okay, yes, that's a fraction. No, I don't need to use quotient rule because it's a 1 on top. So anytime there is just a number on top of a fraction, you can always rewrite it using chain rule idea. Bring it up, big thing with the exponent. Now, what is my outside function on this one and what is my inside function? So my inside is the 2x minus 1. What's my outside? The something to the negative 1/2. Yes? So when I start to do my derivative, I first think of if I just keep that something as my base, how do I do my derivative of that? What do I do with that negative 1/2 power? Bring it to the front, keep the base, and do what to my exponent? Subtract 1. It becomes negative 3/2. And so then this is actually the order I do it in. So like as you watch me, I keep the big base empty until I'm like, okay, now what was in there? That was my 2x minus 1 because I don't want to confuse myself. Then I multiply by the derivative of the inside. What is the derivative of the inside? 2. Now, we do have to clean this up a little bit. With a negative exponent, something goes on top, something goes on bottom. What do we have that's going to go where here? I have this thing with the negative exponent, so where's that going to go? On the bottom. So that's going to be this. Now, what about this? 1/2 and 2, what's going to happen? The 2's are going to cancel and just leave me a negative 1 where? On the top. Yes, ma'am. All right, so I have a 3x multiplied by all that. If we're multiplying 2 functions, what does that indicate? Product rule. But we're in the chain rule notes. Oh, so here's what's happening. You sometimes, like this, are going to have to combine 2 rules in one. Okay? Now, don't panic about it. Take it slow. The overall idea to this one is product rule because it's 2 functions multiplied together. However, the right function is a little bit more complicated, right? So when we get to the part of the product rule where we have to take the derivative of the second function, I'm going to have to use the chain rule for that part. But that doesn't mean I just sit here and panic and say I can't do anything. It means I take it slowly, one piece at a time. So before I do this, I am going to think about it as 3x times 5x plus 2 to the 1/2. All right, so let's walk through product rule slowly on this one. Product rule starts with what? Derivative of the first term. What is the derivative of 3x? 3. Multiplied by what? The second term. Now, I can write it as 5x plus 2 to the 1/2, or I can write it as the square root. I will tend to write it as the power because this is the type where we're going to end up having to factor. So just leave it as the power. Kind of special hint to you. Okay? plus, after that in the product rule, what comes next? The first term, 3x. So far, is this a pretty normal product rule? Yeah, the whole thing through. Derivative of the first times the second plus the first. Uh-oh, here's the part where we need the chain rule within the product rule. This, we have to multiply by the derivative of the second. Well, that by itself needs the chain rule, right? Why does that need the chain rule? Because the outside function is something to the 1/2 power, and the inside function is what? 5x plus 2. All right, so we just practiced that, but let's practice it again. So this is times. How do I do the derivative of the outside function there? 1/2 something to the negative 1/2. And what was inside? 5x plus 2. Times the derivative of the inside, which is what? 5. Now, I did that in a separate color so you could see my chain rule part. Before we go anywhere from there, do we have any questions about where we're at here?
Do we need to put the 5x plus 2 at the bottom of this?
Not yet, because let's talk about this. Do you remember in the prerequisites unit, the packet, we had some of those weirdo factoring questions that you had to factor out like a whole factor of something? Maybe? Maybe?
No.
Okay. Do I need to bring that back up? No? So in your prerequisites, we did some weird factoring where like a whole parentheses of stuff could come out. And we also factored with a negative exponent. Okay? So what I'd like to present to you on this one is that this and this are like terms. Therefore, you can factor that as a greatest common factor. Okay? So if you remember from the prerequisites review, we factored out the thing with the lowest exponent. Which one of those has the lowest exponent? The negative one. All right, so we're going to take out 5x plus 2 to the negative 1/2 power and see what we have left. All right, so I've taken that out front. Now, this is what we talked about in the prerequisites, but again, no one's seeming familiar with this, so I'm going to go back over it. When I pull out 5x plus 2 to the negative 1/2 out of this, remember we said that was like a division problem? Okay, so we said it was like I'm dividing that by this. And what is the rule when we're dividing things with exponents? You keep the base and do what with their exponents? Subtract. What is 1/2 minus negative 1/2? 1. So what is left there is a 3 and a 5x plus 2 to the first power. Are we okay with that? All right. Now here is my second term over here. I've pulled out this already. So what's left in the second term? I have 3 over 2x times 5. It's a 3x, a 1/2, and a 5, right? So I'm going to call that, are we okay with 15x over 2? Or 15 over 2x? All right, now what's the point of doing this? Well, the inside stuff can actually continue to simplify, okay? So what can I do on the inside bracket stuff still? Okay, I can distribute here. This becomes 15x plus 6 plus 15 over 2x. What can still simplify? The x's, yes? Can I combine those? Yeah, I'm sure I'm going to. Those need to have a common denominator though, right? What's the common denominator? 2. So that 15x on the left turns into what? 30 over 2. So total, are we okay with that being a 45 over 2x plus 6? Oops, brackets. Now, here is where once that's cleaned up, where is that 5x plus 2 to the negative 1/2 going to go? On the bottom. Why on the bottom? Negative exponent. So I'm going to drop that down there and make it a root. No. One last thing I need to do. What is one last thing that's not proper here? Yeah, I can't have like a double fraction here. How do I get rid of the 2 underneath the 45? I multiply everything by 2. So if I multiply by 2 top and bottom, my final answer here is going to be 45x plus 12 over 2 root 5x plus 2. I'm going to pause there. We talked about that there was no way to get that 3 out of there, right? We had those lovely rules where you could make that think of as like an x plus 2x, and then you had to do the big expansion, which we don't really want to do that here. Because if I did that here, that would make it like a sine times a cosine plus a cosine times a sine, so double product rules. Yay! No one wants to do that. It's better to think about this as a chain rule. There is an outside function here, and there is an inside function. What would you say the outside function is? Cosine. Cosine of something is the outside function. What then is the inside? The 3x. So the chain rule works great for trig functions. Okay, so if I go through the derivative on this one, I would say y prime is equal to, what would be the derivative of the outside function? Negative sine of something. Now what was in there, just like we did in the other chain rules? 3x. Multiplied by the derivative of the inside. What is the derivative of the inside function? 3. Now the only thing I have to clean up in this is that 3. Okay? Now someone tell me, where does that 3 go? In the front. If this was locked inside at the beginning, this is locked inside here. You may not tell me that is 9x. Don't do it. That is not okay. All right, so the only thing I can do on that is move the 3 to the front and leave it as a 3x. Okay? How do we feel about that? That's a little bit cleaner than the previous one, yeah? Okay. Yes, ma'am.
Would you ever do this and then say like find a second derivative?
It is possible. That one would be an easy one to do with because it just brings a number to the front. So yes.
But you would still keep the 3x if you...
Mm-hmm. Yep. All right, let's look at 5. All right, look at 5 before we answer this question. We are so used to writing this way that we forget what it really means. What does sine squared mean? All of sine is being what? Squared. Okay? I'm not going to say I don't care if you write it this way because you'll get it wrong if you don't write it this way. This means this. Now, why am I being insistent about that? Because you need to think about it this way to say what's the outside function on this one. What is the outside function on this one? X squared. Something squared is the outside function. What is the inside on this one? No. Sine. Sine is inside the squared. So trig functions are only tricky because they can both be the outside or the inside. There is no rule of thumb for whether like sine and cosine are the outside or the inside, other than like, are they inside another function or are they the outside function? So make sure you write it correctly or at least think about it correctly before you tell me outsides and insides. So then to take the derivative here, the first thing I would take the derivative of is the something squared. How do you take the derivative of something squared? Bring the 2 down front, keep the something to the first power, right? But we don't have to write the first power. What was inside there? Sine. Then we multiply by the derivative of the inside. What is the derivative of the sine? Cosine. Now, do I really need to keep those parentheses if there's no exponents? No. I've just done that because we're so used to bring it down, keep the exponents out there. So my official answer to this is 2 sine x cosine x. But knowing what's the outside and the inside on trig is like the big thing. Now, I'm going to really blow your mind on this next one. No. All right. Can someone see why this one is interesting?
Is it chain and product?
It's not chain and product. You could do it that way. There's 2 inside functions. So this one, it's like a h of g of f. There's multiples. All right, so here's the thing. We did chain rule with like an outside and an inside. This one has 3 functions, okay? And before we work out which one's the 3, I always think about like onions. Peel back the layers, peel back the layers. What's that movie that says onions have a lot of layers? I don't know. I don't remember this. Thank you. Things that come to my mind. All right, what's the most outer function on this one?
Squared.
The squared, right? Because this is cosine of 3x all squared. Yes? All right, so if I'm going to break it into pieces, I'm like going from the outside in. Now you're going to think about onions every time you do this, right? Outside function is the something squared. What's the next layer in? The cosine. Okay, so the next layer in is the cosine. And within the cosine is our third layer, which is what? 3x. Before I go into finding the derivative, are we all okay with there being 3 layers to this one? Well, which one do you not think is a layer?
I see cosine squared of 3x.
Okay, well, you tell, which 2 things what do you see as the outside?
Cosine squared.
Cosine, do you know what the derivative of cosine squared is?
It's
Not something we know.
true.
So, that's why there's 2 there. Squared first, then cosine. Well, if you need the help with it, back up to this one. We didn't say that sine squared was cosine squared, right? All right. Okay, so technically speaking, you could have said this one has 3 layers. Squared, sine, and x. It's just, what would the derivative of x be? 1. So you would just multiply by that 1 at the end. So you could keep going, but. All right. Any massive questions about my layers here? All right, so if you have multiple layers, you do the derivative of the first, multiplied by the derivative of the second, multiplied by the derivative of the third. Yes? Now, before I do my layers, I am going to fill in like what was inside of them. Okay? So the outside layer, well, okay, I'll do that as I go. Outside layer was something squared. What's the derivative of something squared? 2 times the something raised to the first power. All right, so now look back up at your equation. What was originally inside the squared? Cosine of 3x. So I fill that back in. That's the derivative of the first one. Then I go to second layer. Multiplied by the derivative of the second layer. What's the derivative of cosine? Negative sine of what was inside the cosine? 3x. Multiplied by the derivative of the third layer. 3. So it's just one long chain. Chain rule. There you go. Yay! Math puns. I'm there. Got to get excited about something here.
Oh, there's one piece now.
All right, now, we can clean this up slightly. Okay? Slightly. 2 and 3 and negative become negative 6. Cosine of 3x, sine of 3x. All right, so on the back, we did questions like this with product and quotient rule, and then you did some like this in your homework. Now, this is chain rule. Okay? So let's look at it. H of x is defined to be f of g of x, aka a function within a function. So what rule must we use? Chain rule. Okay, so if I want to find the derivative here, I just am going based off of my definition of chain rule, right? If my h of x is defined to be f of g of x, we wrote the definition of chain rule on the previous page, right? We said it was defined as f prime of g of x. Now, I'm not writing my x for a good reason because we're told what our x is. And then we multiply by the derivative of the inside function, which is g of x, right? So this is, I'm just copying from the previous page. This is my definition of the chain rule. But in this case, we don't want the x. What number are we plugging in for x? 10. Now, we already know how to do like f of g of stuff. Okay, we've done that before, pre-calculus, algebra 2, all the good places. But let's take this one piece at a time. And this is just my personal preference on these because of how my mind works. One of these is a normal, like f or g of. So that's saying at 10, what is the y value on the g of x function, yes? All right, so I go to 10, I go to g of x, here's that. That is what number? 1. So in my first step, I'm just going to do that because these other 2 things that are in here, are asking me not if this is the x value, what's the y value. They're saying at that x value, what is the what? The derivative, which is the slope. There you go. So I do the first one first, and then I do the slope one second, because it helps my brain to think of that way. Okay? So for f prime at 1, I go to 1. What is my slope at 1? -2. For g prime at 10, I go to 10. Over here, g of x slope is what? -1. Therefore, my answer to this is 2. All right. I'm going to help you write the first line in B, and then I'm going to see if you can finish it. In B, c of x is defined as g of f of x. So it's the reverse, right? So that means the derivative would be g prime of f of 9 times f prime of 9, yes? That's based off of my definition of chain rule. So see if you can find your numbers and plug it in there. Then we're going to proceed back to quotient rule and stuff like that. These are saying q of x is defined to be f of x divided by g of x. Therefore, what rule must I use? Quotient. And then d is f times g. So which rule would you use? Product. Take a minute, set up c and d. And then we're going to do e and f together to finish out. But I will show answers to c and d. Okay? All right, so there's my work for those. Now, I'm going to finish with e and f. All right, so e has defined a new thing here, m prime of 2, where m of x is defined as f of x squared. What kind of rule do you think we're using on this one? Chain. Why do we know that? X squared within the outside function. Okay? Now, all the other ones, I went directly to the rule and plugged in the x value. I'll be honest on this one. My brain doesn't work like trying to plug in the x at the same time. So I went to derivative first and then plugged in x second on this one. Just, it's how my brain works on this. So if I want to find the derivative of this, derivative of that, m prime of x is equal to, the chain rule would say I first take the derivative of the outside function. What is the outside function on this? F of x. So I would say f prime of x, but you keep what's inside. What was inside? X squared. Multiplied by the derivative of the inside function, which is what? 2x. Okay? On that one, I do find it better for me, like I said, to write it with the x's first. I would have gotten confused trying to plug in the 1 until now, or whatever I'm plugging in 2. I'm plugging in 2. That's what I'm doing. All right, so if I want to do then m prime of 2, what are they asking me to do with that 2? Well, I'm plugging it in for the x's, yeah? In that case, it's going to be squaring it. So m prime of 2 is going to be f prime of, if I plug in x is 2, that's going to be 2 squared, right? Which is what? 4. Times 2 times 2, 4. All right, well, let's go back up to the graph. How do I find f prime of 4? Slope at 4. So I go to my graph. At 4, my slope of f of x is what? 0. F of x. It's the bottom one, this one. So that slope is what? 1/2. So that is 1/2 times 4, which is just 2. All right, and our final question of the day. Final question. Equation of the, keyword forgot here, tangent line. We just talked about this. What does equation of a tangent line need? Okay, I need an x, I need a y, I need a slope. What do I have? An x. All right, so I have my x, I don't have my y, I don't have my slope. How do you find slope? Plug in x to the derivative, yes? So in our notation here, what would you write that as? Well, what's our function? H prime of 10. All right. Where did we define what h was? Way back up at the top. And, oh, look at part A. What did we find in part A? h prime of 10. We already found that. What did we say way back here? H prime of 10 was 2. That is my what? Slope. Yay. Now, what's the only thing I'm missing? Y. How do you find a y value? Plug it into the original. Have I done that yet? No, but above, h of x is defined as what? F of g of, in this case, what? 10. Okay, because I'm plugging in 10. Yes? That I'm just getting from, if I go way back up here, this was my definition of h of x. Yes? F of g of x. So to plug in 10, I'm doing or f of g of 10. We've done this before, so what do we do first? I do g of 10 first. Where do I find g of 10? On the graph. So I go to my graph. At 10, what is g of x? 1. All right, going back here. That then is f of 1. Yes? So I go back to my graph. F of 1 is 2. All right, so are we ready to write our equation of our tangent line? Yes. All right, so we do y minus, what's my y? That 2 that I just got. Equals, what's my slope? 2. X minus 10. Yay! There we are. Clap for us all.